All right. Yeah, I was supposed to go to the Broncos-Cardinals game on Thursday. Those tickets fell through, and I was able to go to the Arizona State-Stanford game, which was pretty cool. I've been in that stadium since I graduated. Man, that was a long time ago. And then had lunch with a couple guys I hadn't seen since the early 80s. That was good. I enjoyed it.
Were those the graveyard people?
No, I saw some of them. Okay. L. All right, let's take a look at worksheet L. I'm not going to mark it off because if I do mark it off right now, there's going to be half of you who have it, and the other half are going to be upset because, it's the only thing I've ever done in life. Good. So it's a good thing I'm not collecting it. Fall cleaning. Questions on L. 6.
26.
Number 6 starting out. Let's see if we make this one work. Number 6. We have
I don't know.
okay. So I want to go ahead and see if I have a greatest common factor. It looks like I can factor a 2 and an x out of both. That leaves me x squared minus 4 is equal to 0. Is that okay so far? And then, so this is going to give me 2x is equal to 0, so x equals 0. This is going to give me x squared minus 4 equals 0. I could factor it, or I could just move the 4 over, take the square root of both sides. So I get x equals plus or minus 2. So the crossings of the x-axis happens at -2, 0, and +2. These are all rational. Okay? Irrational would mean they'd be like the square root of 5. That'd be an irrational number. And none of those are imaginary. That's 6. What else? Someone said 26?
No.
No? Was 26 one?
Can you do
9?
9?
Yeah. Number 9. X plus 5 quantity squared equals 16. Okay? I want to take the square root of a quantity and a square root of this. Don't forget there's a plus or minus there. So I get x plus 5 is equal to plus or minus 4 because square root of 16 is that. Subtract 5. So I get -5 plus or minus 4. So -5 plus 4 is -1. And -5 minus 4 is -9. Those are both rational roots because they will cross it exactly where you want them to. What else? $30. Okay. 30. I get 4 quantity x plus 2 quantity squared plus 1 equals 0. I need to start moving everything over, so I'm going to subtract 1 from both sides first. Is that okay? Divide by 4. Is that okay? Everyone okay with what I've done so far? So I want to take the square root of both sides. Don't forget the plus or minus. So I'm going to get x plus 2 is equal to plus or minus I root 1/4. Root 1/4 is 1/2. Okay, so then I'm going to get x plus 2 equals plus or minus 1/2 I. So when you have a radical, you bring the I out front. If the radical breaks down, then the I goes out back. And then I'm going to subtract 2 from both sides. So I get -2 plus or minus 1/2 I. Okay? Though that worked out nice and neat, we had this I that's sticking along, so that means that the roots are imaginary. These roots don't cross the x-axis. They could make the graph wiggle a little bit or change directions a little bit, but they won't cross the x-axis at those, nothing on there. Anything else? Do you want? I'm sorry? Never mind. We good to go? All right, so if that happened to be the only assignment you ever did in your entire life and you feel completely gypped, come talk to me at a later time saying that was so unfair that I didn't collect that. but I'm pretty sure with the other 740 pages I collected, it probably didn't influence your grade one way or the other whether I collected that or not, especially because if it doesn't go on the grade book, it doesn't affect your grade. 5. So this does seem like a thick packet of notes. I'm not going to do necessarily all of them, but we are going to start working on that completing the square. If you trust me, I will get you through the completing the square, but don't let me move on if you don't get a certain concept on it, okay? Completing the square, in my opinion, is the best skill that we could get out of math class. I love it, but a lot of people are like, they're frightened of it because a lot of times you come up with fractions and you see a fraction and you totally freak out because it's a fraction. Did I hand out enough notes, everybody? We're good? All right. And if I skip something, it doesn't mean it's not necessarily important. I just don't feel that it's going to be the best thing for you all to focus on completing the square. Completing the square means you are creating a perfect square trinomial. Meaning if you were to break a perfect square trinomial down, it would break into the exact same two binomials. So rather than you factoring, getting like x plus 3 and x minus 7, those are two different binomials, you would get the same binomial twice. You get like x plus 2 and x plus 2, or x minus 6 and x minus 6, or 2x plus 3 and 2x plus 3. That's what I mean a perfect square binomial. Okay, think about what a perfect square is, like 1 and 4 and 9 and 16. Take the same number times itself. Perfect square trinomials is take the same binomials, multiply it by themselves. All right, so if you multiplied these out, I'm just multiplying them out quickly. I'm not showing you how to FOIL or double distribute. I think you should be okay with that. Does anyone need to see those worked out by hand a little bit further? So the ones that are now in red are all perfect square trinomials because I took two of the exact same binomials and multiplied them together in order to get there. Does this seem okay so far? This is Algebra 1 right now. And a few things to think about. If you were graphing these as parabolas, these create something called a bounce off the x-axis. Okay? So this would have a bounce, and you don't have to worry about the bounce, but this means that the direction would change at 4. The direction on this would change at -5/3. This is both variables, so we don't get a bounce because of variable. A bounce means it's where the vertex is of the parabola, but a bounce later would mean where it bounces off the x-axis, the other from the bottom, or you hit it off the ceiling and came back down. I'm skipping. All right, I'm going to go down to the factor these. And I hope you have these. This should be the bottom of the second page, I believe. Hey! Hello. At the bottom of the second page. Good to see you.
Good to see you too.
I don't know why that, it's... Okay, so if I factor these quickly, this is going to be x plus 5, which is the same thing as x plus 5 quantity squared. And I'm not worried that we're not it's like, oh, how did you factor that so quickly? It's just, that is a perfect square trinomial. Basically, how you look at perfect square trinomials, x times x is x squared, 5 times 5 is 25. Those are both perfect squares. If I multiply the front and the back and double them, I get the middle term. That's the in and out. Do I really worry that you can recognize perfect square trinomials? Yes and no. The quicker you can see these, the quicker it's going to factor for you. Okay? If you're not, able to do these a million miles an hour, you still do it by our old way of factoring. Number 3 and number 4, a lot of people will steer away from it real quick because there's a fraction. Agree?
Agreed.
But you look at 49 over 4, that's the same thing as 7 over 2 times 7 over 2. So if you look at this and you look at this, oh, those are both perfect squares. So realize that sign has to be dictated. That's all it is. So again, if you can recognize that you have perfect squares, and a lot of times they will throw something like that because they know that a fraction will deter you, especially on ACT or SAT or any of those standardized tests. Mr. Watson. Your brother make you late? Yeah. Okay, it's his fault. I'll mark him tardy then. Thanks. We're at like the bottom of the 3rd page. And then this one. Is that a perfect square?
Yeah.
Yeah, 1/2 times 1/2 is 1/4, correct?
Yep.
So that's going to be x plus 1 over 2 quantity squared. So again, those trinomials up above were all perfect squared trinomials. They factor into the exact same binomial, so you could write it as the binomial twice, which if you were solving like this, you would just have to take the square root in order to get things by themselves. Is there anything that I've covered so far that's like, dude, it's gone? So here's the nice thing. If you start seeing a fraction on a quiz or something like that, that falls in that last position, it's very possible we gave you a perfect squared trinomial, so don't panic it. Just go and figure it out. Okay? Let's see. All right. Ready? It's as simple as this to complete the square. Eyes up here. What's half of 12?
6.
What's 6 squared?
36.
Done. And that's going to allow this to be x plus 6, x plus 6.
It's a little simpler than what you taught us.
That's as simple as I can go. You look at the b term, that's actually called the linear term of the quadratic. This is the quadratic, linear, and constant. If you're completing the square and you don't have a lead coefficient that is, if it's 1, it's half of this, square it, done. That's it. Okay? And it's like, well, make it tougher. It's not. It's half of the b term squared. That's all it is. Can I move on? Oh, wait. There's stuff down here.
So, what if there's like a number in front of it?
We'll get there.
Okay.
We're getting there. All right, ready? Half of that is?
6.
Square it.
36.
So then if that were the case, this would, see, notice that's a positive 36?
Yep.
This is always going to be a positive term when you're completing the square. So this is going to give me x minus 6 times x minus 6, which is the same as x minus 6 quantity squared.
Plus 81.
Plus 81? Yeah, because half of 18 is 9. 9 squared is 81. Okay? And then if that's your factor, it's going to be x plus 9 quantity squared. That's really all there is to it. There's a lot more people that put so much more thought into it, and there shouldn't be. It's just, here it is. It's the same process as you go through. Okay. Do you have all these slides that I've already hit?
Mm-hmm.
Good. I didn't have any blanks. It's because I made the copies before break. All right, what's the C value on number 7? 16. What's the C value on this one?
1/4, right?
1/4. Right. Because what's half of 1? Half. What's half squared? 4th. So now we're running into a little problem. We're going to cover that in a little bit. Yeah.
For the last one, for the 1/4, how would you do like the parentheses things that you have here?
On this one?
Yeah.
So this would have been x squared plus x plus 1/4, which is x plus half, x plus half,
Oh, so it's x plus half squared.
or x plus half quantity squared.
Okay, thank you.
So I'm going to come back to this one in a little bit.
Okay.
Okay? This is one that has a lead coefficient that's not 1. Agreed?
Mm-hmm.
But let's go on to number 10.
C 1.
Half of 2 is 1. 1 squared is?
1.
So that would be x squared minus 2x plus 1, which factors down to x minus 1 quantity squared. Okay? Quick stuff. And again, I'll come back to number 9, but it's the same thought process once you get that lead coefficient to be 1. Half of 5. Keep it as a fraction.
2.5.
Keep it as a fraction.
5
5 over 2. 5 over 2 squared is?
25 fourths.
25 fourths. Okay?
Can you do 6 and 1?
So if I do this, and the reason we want to keep it as a fraction is easier to take half of a number. Okay? So this would factor out to be x plus 5 over 2 quantity squared. Okay? Keep it as a fraction. I promise you it'll be better for you even though you dislike fractions. This is like the gentle fraction stuff. What's half of 7 as a fraction? 7 over 2. What's 7 over 2 squared?
29 fourths.
Okay, so this is going to be x minus 7 over 2 quantity squared. That's all it is. Okay? Doesn't seem too tough right yet, does it? It's going to be the same process we're going to continue to use. If you want to take half of a fraction, you double the denominator. So what's half of 7 over 8? 7 over 16ths. What's half of a half? A fourth. What's half of a fourth? An eighth. What's half of an eighth? A 16th. What am I doing? I'm doubling the denominator. Okay, the denominator's on the bottom. It's that simple. But for some reason, some math person at some point said, oh, there's fractions. We're going to screw everybody up with fractions because everyone hates fractions. And it's like, dude, no. You want to know why I did cruddy with fractions when I was in school? Mrs. Patterson, 4th grade, Introduction to Fractions. She's going to read out of a booklet, because she doesn't understand math. Okay, be sure you do this. Let's say you have 1/4 of one pizza and 2/3 of another pizza. You know what my mind just did? Dude, she's talking pizza. I want lunch. She lost me. I'd be like, no, what kind of pizza? Is it Smitty's or Nello's? Oh, Chris, we're not worried. No, I want to know. And she's like, okay, why don't you go sit outside? Okay, is there pizza out there? Yes, okay. Yeah, I apologize, but Mrs. Patterson, she wasn't a good teacher.
That's okay, my 7th grade teacher messed math up for me.
My 7th and 8th grade, exact same teacher. You know what my 7th and 8th grade math teacher told me?
What did she tell you?
Don't ever do anything related to math. You have no clue.
She was right.
You got that right. All right.
Oh, wait.
Actually, square. I don't know. I want to move off of these. I'm not trying to focus on those right away. All right. So I'm at this one. Looks like number 16. So now we're in the process of what will we do once we got a perfect square? Well, from here, I'm going to take the square root of both sides. And remember to have a plus minus. So that becomes x plus 4 is equal to plus or minus 5. Subtract 4. And if it comes out to a perfect square, then you go ahead and do the math. So you get 1, and you also get negative 9. Negative 4 plus 5 is 1. Negative 4 minus 5 is negative 9. It's an addition and subtraction problem. What's the plus minus? This one, I get root, so I get plus or minus. I don't know what the square root of 7 is, so we just leave it as square root of 7. This is an irrational answer, meaning it will cross the x-axis, but I don't know exactly where it will cross because square root of 7 is a decimal that goes on forever without a pattern. So from there, I just add 2 to both sides, so my answer becomes 2 plus or minus root 7. So your solutions to this problem are 2 plus root 7 and 2 minus root 7, but we shortcut it by putting the plus minus in there to give you 2 different things. That's Algebra 1 still. Are we still with me?
Yep.
Anyone stuck? You didn't learn Algebra 1? Then I can try and force it down right now, but we'll see. How am I doing so far?
Pretty good.
Amazing.
Can I move on?
Yes.
Gold star.
All right. So now, we want to use completing the square to solve these.
Is this new?
This is new.
Oh no.
So put a star
Is
or a
it
smiley face because you know this is brand new. I'm going to walk through it real slow for you. If there's an equal sign, you move the 9 over. Okay, notice I left a space as well. You still with me? Is there any part of what I just wrote up there that you're like,
No.
I mean, leave a space. You move your C term. You leave that space open. In order to move it to the other side of the equal sign, you have to subtract it. You good with that?
Yes, sir.
Huh?
Just wait. Just wait.
Let it happen.
All right. Half of 10.
5.
5 squared.
25.
Filled the space. If I add it to one side, I have to add it to the other. Keeps it balanced. Do you agree?
Yes.
Okay. Does anyone know what this factors down to quickly? Anyone knows?
X plus 5 squared.
Do what?
X plus 5 squared.
X plus 5 quantity squared. Good job. Do the arithmetic here.
Why did we add the 25?
I completed the square. I completed the trinomial to make it a perfect square trinomial.
Yep.
And then you do.
And then we just did this, right? Root, plus minus.
Okay.
I understand.
Thank you.
Subtracting the
That's
5.
all we're wondering.
Oh, look, we've only done this one so many times. -1 and not -9. -1, negative.
Okay.
Agree?
Agree.
Anything about that? You're like, hey. Does everyone see what happened with the space?
Yes.
We filled it with the completed square.
Yes.
It's not really a mathematical term saying, hey, make a space.
Uh-huh.
Yeah, you do understand this?
I do.
You really want what?
Move on.
If anyone was spacing out, they probably missed it.
All right, here we go. Yes or no?
Yeah.
Yes.
Yeah.
Anyone like, hey, wait.
No.
Half of 20 is
100.
10, 10 squared.
100 is
If I add 100, I also have to add 100 to the other side. Agree? We good?
Yeah.
What does this factor to +quickly? X plus 10 quantity squared. Good. 25 added to 100 is 125. Root, plus or minus.
Wow.
X plus 10. I know that 125 breaks down to 25 times 5. Do you agree with that? The reason I'm doing that is 25 is the largest perfect square in there. So this is going to break down to plus or minus 5 root 5.
Wow.
Now that's going to be where some people are like, wait.
10 plus or minus.
You okay with that?
Yes.
Took the square root, brought it here.
Yep.
Yes.
Then I subtract the 10.
Yep.
This is an irrational answer because the square root of 5 is a fraction that goes on and on forever. It doesn't repeat, doesn't have a pattern to it. So my answer is -10 plus 5 root 5 and -10 minus 5 root 5.
Yep. Wow.
You're completing the square. It doesn't seem that tough, does it?
No.
And my whole motivation on this is I don't want it to be tough. I don't want you to be going, dude, I'm going to cry myself to sleep tonight because this stuff sucks. Okay? It's a really easy concept that if you have a teacher who struggle with math, like me going, pizza, yeah, baby, then I comprehended it. It makes sense because I get the kid whose mind wanders and is like, dude, I hope like a bee falls on somebody's head in the middle of class. I'm that kid, yeah.
I just have a question for number 18.
Yes.
So is -1 and -9 like the final answer?
Yeah, that's where it would cross the x-axis. It would cross at -1, 0 and -9, 0 if you had y equals.
Okay.
It'd make a parabola. Those are called the roots, okay, or the solutions. Can I move on? Is everyone good?
Yes.
We comfortable? Does your neighbor have tears in their eyes?
Yes.
Good.
Not yet.
Not yet.
Olivia.
All right. Solve each by completing the square. Same thing. Agree?
Yes.
Half of 6. Notice I didn't say half of -6, correct? Half of 6 is 3. 3 squared is 9.
That's fine. Yep.
Is that okay?
Yes.
Why is it negative 3?
Because it's negative 6.
Negative 6. Root. Don't forget the plus minus. Oops.
Wrong.
Thank you, Olivia. They're helpful insight on everything.
3 plus or minus 2. 3 plus 2 is 5. 3 minus 2 is 1. Those are my solutions. Again, if this was y equals, we can make a parabola. That's where it crosses the x-axis. These are real solutions. These are, you could definitely see exactly where these cross. All right. You know that curveball you were waiting for?
No. Now
Here it
it's
comes.
negative.
So we have a negative out front. Let's see if you can figure out what I just did right here.
You took away the negative.
What did I do to everything now?
Negative.
Multiply by-
switched it. You switched it.
Yeah. Now you're going to get the one kid who's puzzled and back saying, why is it not negative 0? Well, it could be. Negative 0 is the same thing as positive 0 because 0 is signless. Okay? I have to say it because I know people in here are going to go, you changed all the signs. Basically, I multiplied everything by a negative 1. I changed all the signs. You multiply 0 by a negative, it's still 0. Okay? Then we can go about doing our problem. Agree? Add 36, add 36. What's going to happen when I go root?
What?
What's going to happen when I go
It's gonna
root?
go. It's gonna go the I.
There you go. So I go root, plus or minus, x minus 6 equals plus or minus.
2I root 2.
There you go, 2I root 2. The reason it's 2I is because I can break 8 down to 4 times 2. Square root of 4 is 2, so it comes out. So this is now an imaginary root. This root does not cross the x-axis. Okay? Why?
No,
Sorry, I'm trying my
You
hardest.
got our math class last year.
No, I'm trying my hardest. You said this is the worst class
No, I
ever.
love this class.
Watson, you heard her say it, didn't you?
No.
I'm feeling a little upset.
I mean, I was in her math class last year and it's bad. No, we were in math together.
No, you can't backtrack. I heard you what you said.
All
All right, here we go. Here we go. Hey, shh. It's not a variable. That means I had a negative in the square under the square root. Okay, I'm going to add 6. The I, it came from right here. Square root under the radical. So 6 plus 2I root 2 and 6 minus 2I root 2. What number does that match up with? That is an imaginary number. When I say imaginary, it's not in the land of make-believe. It's not made up. It's called the imaginary number system. Why did the people in the world of maths decide, hey, we're going to start naming number systems that's going to jack up the world? Hey, we have the real number system. People have, of course it's real, you moron. Okay? And then you have the imaginary going, what, were you like in cartoon land? No. I don't know why these math people decided it. Maybe they thought we're doing stuff that people all hate, so let's really make them hate other stuff. I don't know. I wasn't at the meeting. I'm sorry. Can I move forward? Is there any questions here? Yeah. Well, we're getting there. It's coming. Okay, this one we're going to start dealing with some fractions. Ready? Yes or no?
Yes.
Half of 5, leave it as a fraction.
5/2.
5 over 2. What's 5 over 2 times 5 over 2?
25 fourths.
25 fourths. Agree? Agree?
Yes.
All right, so here's my complete square. Ready? What was half of 5?
5 halves.
5 over.
Did you see what I just did?
Yes.
So that sign matches, half of that is here. Oh, okay. Well, I got to make that 40 over 4 plus 25 over 4, which is 65 over 4. Agree?
Agreed.
Didn't try to make it too difficult.
Oh, and then you do the root thing.
Root. Don't forget the plus minus. X minus 5 over 2 equals plus or minus. 65 won't break down, but 4 breaks down. Notice I was able to take the square of the denominator. So now I'm going to add 5 over 2 to both sides. I would leave it like that. Sometimes people would say, hey, this is the same thing though. And I agree, but I'm fine with this answer here. Which one do I prefer? I like this one. I won't mark you wrong on that one. If it was a multiple choice answer, we're giving you this answer and not this one. And I'm not going to give you both answers saying which is more correct to really screw people up. I always love that question. Hey, which is more correct here? I don't know. Can I go back to the pizza? May I move forward?
Yeah.
Life good? All right. Here is the question we have been asking for. I have a lead coefficient, my a value, the value that is attached with my quadratic term, which is the term that's squared, is no longer 1.
You divide it by 2.
So what I'm going to do is I'm going to divide all the terms by whatever that is. I'm even doing it over here. But what's 0 over 3?
0.
Yeah, you see? So this is going to give me x squared plus 8x plus 5 equals 0. You okay with that?
Yes.
Move that 5 on over. Half of that squared. So this is x plus 4 quantity squared equals 11. Root, don't forget plus or minus. Root. And that's what you do when you have a lead coefficient that is not 1.
Perfect.
Okay?
The next one, though.
Oh, the next one. Forget about it. Divide everything by 3. Oh, no. But I got a fraction.
Yeah.
All right. X squared. Make a space. Same rules. Still with me?
Yeah.
Half of 4 is 2. 2 squared is add 4. Yay. This is going to be x minus 2, which is x minus 2 quantity squared. And I could make 4 the same thing as 12 over 3. Agree?
22 over 3.
Oh, close. There's a negative there. Negative.
2 over 3.
There you go. What's next?
Square root.
Root. Don't forget the
Root. Plus or minus.
Oh, shoot. Look, I got the denominator with the radical there. So I'm going to make that a perfect square before I move anything. So that's going to give me plus or minus root 6 over 3. Because I multiply top and bottom by 3. 2 times 3. 3 times 3 is 9 squared, and 9 is?
Then it's 2 plus or minus 6 root over 3.
Yep, so x equals
Perfect.
2 plus or minus root 6 over 3. Root 6 over 3 is the only thing that has a fraction to it. I didn't do a whole lot of fraction stuff there. What kind of answer is this? It's not imaginary.
Irrational.
It's irrational because I know about where it crosses, but not exactly. Okay? Root 6 is a decimal. It goes on and on forever. Doesn't have a pattern. Doesn't repeat. Like pi. Okay?
Yeah.
And yes, I understand there is some kid that every school there you could take out pi, 155,000 spots, and you're like, but why? Though it's kind of amazing to watch, and I think it's a fun circus act, mathematically, is it going to really help you?
No, it doesn't.
Nothing mathematically helps.
You already said this is the worst class you've ever taken. Now, nothing math. Freaking math.
I like this class.
Yeah, you're just, see?
It's fun. I don't like math.
You're like
but
my
I
wife.
Like this
She
class.
insults me under her breath saying, but I love you. And I'm just kidding.
Sorry.
All right.
It's just joshing.
No joshing.
Who's
Who's Josh? Okay. So use what we know about completing a square to turn this into vertex form.
Divided by -1.
Okay, so that's my first step right here. Agree?
Yes.
Is anyone stuck there?
No.
Eyes up there, you get that?
Yes.
Okay, so it's not equal to 0 right now. It's equal to
Y.
y. Okay, see if you can figure out what I just did right here.
Oh,
You just
space.
left space. You left the space.
Did.
Wow.
Okay. See if you can follow this. Half of 4.
2.
Square that.
4.
So plus 4. If I'm on the same side of the equal sign to keep it balanced, I could go plus 4 over here, or I could go minus 4. Agree? So think about this, what this really was. I could have went plus 4 over here because I added that 4. Or I could move that back over by subtracting. Here's my complete square. What does that factor to?
Y minus
-2
2 squared.
X minus 2 quantity squared. -1 minus 4.
-5.
-5. I had this negative back in the beginning. I'm going to bring it back. I'm going to multiply everything by -1. Does this parabola open up or down? Down, because my lead is a negative. What is my vertex?
5 and 2 and 5.
So my vertex is opposite and +5.
Oh wait.
2, 5.
2, 5. Opposite grouped, same outside. So 2, 5. 2 and 5, we're like right here. We pattern graph it. It opens down, so it'll go right 1 down 1, left 1 down 1. Right 1 down 3, left 1 down 3, right 1 down 5 if I want to keep going.
That's a good graph.
Anybody know what kind of solutions are here and here? Irrational. I can see about where they cross. I don't know exactly where because they are going to be square roots of something. How would we solve those? We'd make that 0 and then solve it.
Is that it? Yeah.
That's it?
Yep.
I went through that whole packet that quick.
Good job.
Man, that was fun.
Yeah, baby. All right, now let's just make sure your homework makes sense. Yes, 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 and yes. Okay, so homework for all of you tonight is worksheet 5M. Guys and girls, listen up, listen up. We are starting to get into thicker math. Agreed? So guys and girls, listen up. I am off these periods, 1st, 2nd, 4th, and 7th.
Dang it.
If you are off a different period and you want to meet after school,
I can't do that either.
well, there's only so much I can do. You want to meet after school, you all have my cell number. Send me a text. Send me a text saying, hey, can I meet you after school? And give me your name because I don't have your name in there. I'm not going to save your name.
Hey, yo, what's good?
Okay?
We have like 800 contacts.
If after school doesn't work for you, before school is really tough, but I do get here at 5:30. I do have the med class that does start at 7, so if you want it before school. Is that cool?
Yeah.
Usually at about 6:30, I head over to Schilling Law. So if you're on campus, there's no one here yet, we go to Schilling Law and you get help. But those are the times you can get help. This is new material. So it's very possible there's a whole lot of Chris Stirrups in this class, which I don't think there is. I think I'm the only one. But a lot of times when I walked out of math class and I opened up my math later in the day, it was just like, what is this? We good?